This video will go over part 1 of my trigonometric integration techniques for Calculus 2, and in this case we're going to do powers of sine and cosine and how to integrate them. And before we begin, if you're wondering on how to do secant and tangent as well as cosecant and cotangent, I will make videos on that after that. So that's why this one is part 1. But anyways, we're going to encounter two types of these sine and cosine integrations. Type 1 is going to be if both of your powers are odd. Now in this case, if m were to be 3, that would be odd. If n were to be 5, that would also be odd. And so in this case, you would use this formula, which you can split into two different formulas, which are sine squared of x equals 1 minus cosine squared x, as well as cosine squared of x equals 1 minus sine squared of x. So with this in mind, let's say we want to split up our cosine of x. One way we could split it up to make that cosine squared of x satisfied is to do cosine squared of x squared times another cosine of x, which will be equal to cosine to the 5th power of x. And now that we've satisfied that cosine squared, we can just rewrite this as 1 minus sine squared of x squared times cosine x. And you might be wondering, well, what was the point of that? And that's the whole point of this video. I will explain that later. Now, a different type that we're going to encounter is that both of your powers are even. So for example, if our m equaled 2 or if our n equaled 4, which are both even numbers. So with a case like that, we would use these two formulas to substitute in, similar to how we used these two formulas up here to substitute into the odd powers. And a good way to remember these, well, at least a good way for me back in trigonometry, was that the cosine would be negative because the cosine didn't like sin, but the cosine would be positive here because the cosine liked another cosine, if that makes any sense. And what's flawed about that is you also have to remember the 1/2, and then you have to put the 1 minus or 1 plus for that charge on the cosine, as well as knowing that there is a 2x, and that will get doubled in certain cases, such as using it twice in the same problem. So let's get into our first example. So for problem 1, let's find the integral of sine cubed x dx. Now notice our power is odd, so we will refer to our sine squared x plus cosine squared x equals 1 formula. Now since we are trying to substitute sine, let's just solve for sine in this formula, which of course leads us to sine squared x equals 1 minus cosine squared x. Now to be able to use this sine squared of x, we obviously have to split this sine cubed of x, which won't be too difficult because we could just do sine squared of x times another sine of x. And of course, don't forget your dx. And now that we have a sine squared x here, we could substitute this version of sine squared x, which will be underlined in red, which will then get us 1 minus cosine squared x times sine of x. Now you might be wondering, well, that kind of felt pointless like earlier, but it's not, because then you could use u substitution, which in this case, we would try to cancel out this sine over here. So let's get cosine to be our u. And how does that cancel the sine over here? Well, it's derivative, which is negative sine x. And our dx equals du over negative sine x, which if we plug in to this dx, we will get du over negative sine of x. Now again, since we know that our u is cosine of x, we will erase this inside and replace it with 1 minus u squared. Now these two signs will cancel out, leaving us with this negative sign over here, which we could put outside of the integrand. And we are left with 1 minus u squared du. Now from here, we're given a fairly simple integral, which we can just evaluate as u minus u cubed over 3. And then applying that negative outside of the brackets will get us negative u plus u cubed over 3. And also don't ever forget the plus c. Now if you remember from our u substitution video, are we done? No, we still have to plug in our u, which was cosine of x. So now we're left with negative cosine of x plus cosine cubed x over 3 plus c. And if you would like, you can always just rearrange to make the positive go first. And now we have successfully solved an integral with an odd power. I would now like you to do this more difficult problem on your own real quick. Now the first thing that you'll notice here is that we have an odd power on sine. So we could split that up into sine squared x, which is squared again, times another sine of x, times the remaining cosine squared x dx. Now knowing our identity for the sine squared of x, we could substitute it with our 1 minus cosine squared of x into the brackets. And don't forget the square times the sine of x times cosine squared of x dx. Now over here, we could finally do our u substitution, making u equal to cosine of x. And the reason for that is because we want to try to eliminate this sine of x right here. This will then make our du negative sine x dx, and making our dx equal to du over negative sine x. Now that we have all of that information, we know that every single cosine will be u. So this becomes 1 minus u squared. We know that this sine of x cancels, which leaves us with another negative sign. So let's put that outside here. And by the way, it cancels because this dx became this over here. And then we multiply with another u squared because our cosine is our u. And then finally, du. Now you could FOIL this 1 minus u squared out, which I'll just demonstrate here, which leaves us with u to the 4th minus 2u squared plus 1, all multiplied to this u squared. We could then use distributive property to multiply this u squared to every single term, which gives us this polynomial. This will be pretty straightforward to integrate, so we're just given u to the 7 over 7 minus 2u to the 5th over 5 plus u cubed over 3, and of course our plus c. Now are we done? No. We know our u is cosine of x, so every single u is going to be cosine of x, which leaves us with cosine to the 7x over 7 minus 2 cosine to the 5th x over 5 plus cosine cubed x over 3 plus c. And don't forget the negative sign outside. Now with my professor, this is going to be a completely acceptable answer, but maybe some of yours don't, so just distribute this negative throughout all of these if needed. Now the first thing you'll notice looking at our third problem is that the power for cosine is even because it's the number 2, which is an even number. And we know that when we have even powers, we use our power reduction formula, which in this case we would use cosine squared of x equals 1/2 times 1 plus cosine of 2x, which you remember because of my amazing analogy of cosine liking another cosine. We can then substitute that in to our cosine squared x, which just gives us 1/2 times 1 plus cosine of 2x dx. Now since 1/2 is a constant, we could take that out of our integral, and now we're left with the 1 plus cosine of 2x inside the integral. We could then simply integrate this, but first let's try to integrate this cosine of 2x first. In this case, this is just a simple u substitution, making u equal to 2x, du equal to 2 dx, and dx equaling du over 2. This then leaves us with 1/2 sine of 2x. And knowing that, we could just integrate everything, which is 1/2 times x plus 1/2 sine of 2x plus c. And distributing all of this, we get 1/2 times x plus 1/4 sine 2x plus c. And there we go. Now, last but not least, I would like you to do this problem on your own. Now, if you couldn't figure it out, this one does use power reduction twice, and you may have slipped up somewhere, which I will assure you to not do again if you did slip up. So in this case, since both of our powers are even, which luckily are both 2, we will just use power reduction on each one, which using the formulas will give us this evil function. And turns out we could just factor out a 1/4 because of these 1/2s, which gives us 1 minus cosine 2x squared. Which, if you're wondering how I got that, all I did was just FOIL the rest of the equation. Now this is where things get a little bit tricky, because in this case, we will use power reduction again, which might seem easy enough because all you have to do is replace the cosine squared with 1 plus cosine of 2x, right? Well, this is where you'd be wrong. Every single time you use a power reduction, you will always multiply this inside parentheses by 2. So notice, all the way back here, in the original formulas that I gave, this is originally at 2x, because this x was originally 1, and multiplied it by 2, and eventually made that 2x. Now same would go for over here. Since this was 2x over here, we will multiply it by 2, which would then give us 4x. So please be careful with that. So then now we are finally integrating 1 minus 1 plus cosine of 4x. Oh, I apologize, I forgot my 1/2. Hopefully that didn't confuse you. We are then finally going to simplify this integral to 1 minus 1/2 plus 1/2 cosine 4x using distributive property, which finally gets us 1/4 times the integral of 1 minus 1/2 minus 1/2 cosine 4x, which combining these like terms would then again simplify to 1/4 times 1/2, well the integral of 1/2 minus 1/2 cosine 4x, which you can simplify even further by just taking out a 1/2, which I'll just show fully here, which because this 1/2 is a constant, I'll just keep going down here. We can make that 1/8 times the integral of 1 minus cosine 4x dx. Now we can finally integrate. That will give us 1/8 times x, and then the integral of this cosine 4x we'll do on the side real quick. Again, this is just a simple u substitution, which leaves us with 1/4 sine of 4x. Now we can subtract that from the x over here, and then add a c. Now if you want to distribute this even further, this just gives us 1/8 x minus 1/32 sine of 4x plus c. And we are finally done.